All right, this is all jail stuff I've pulled up here. That's not what I need today. All right, so this is conn.lick and conn.c, which are all interprocess communication components that have slightly different roles and philosophies in the way that everything's put together. So in some ways, I mean, so Ames and Clay are pretty heavy duty Unix facing veins. Touching the file system and touching the networking stack are definitely relying on the host OS very explicitly. Conn and Lick are different in that they are more they're just abstract process controllers, right? Like they're just capable of doing certain things with conn is generally for things to be injected and executed into Urbit, whereas Lick is more about running sidecars with mutual communication to and from Urbit. And it would actually be an interesting experiment to see if you could recreate an Ames or a Clay sidecar using a vein like Lick, like what actually could be pushed off as far as the bar mount, bar commit, that sort of aspect of it. So at the sort of our summary view of these is, so conn is a vein that's a high level thread interface. It actually doesn't run threads directly. It passes them off to Spider, which is inside of Gall, which we talked about a couple weeks ago. Lick is a low-level noun interface instead. And basically, this is saying we're going to treat Arvo as a server and some Earth software as a client. And then conn.c is somewhat related to conn, but not directly. And it's basically administrative control instrumented via the runtime. So as I said, conn is, we'll start with conn. Conn is how we trigger threads from outside of Urbit. But to really talk about that, we have to say, okay, like what exactly is a thread? Have you written threads much before? Any of you?
Only for conn and conn.c. It's the only time I've used threads. Other than that, not really.
Mm-hmm.
I think I remember writing one for it was a school homework or an app school homework. Other than that, not really at all.
Yeah.
Yeah, I've looked at them a couple times, but never written one.
Yeah. I think at this point, if you think about, what you know about Arvo and Gall and everything, if I paused, which I will not do, and asked you to sort of sketch out like how you think threads work, you could probably do a pretty good job of predicting like what they are. As we step down, Arvo is an event handler for OS level moves. Gall's an event handler for agent level moves. And there's Spider, which is an agent inside of Gall, which is handling its own state of transient thread level operations. And so everything's nested down inside of all these different operations. So there's some overhead that you pick up because the dispatches have to take place, via, if it asks for something, it has to go via Gall, via Arvo, all the way back out. But in general, Spider just handles what's actually happening with threads. So the technical definition is a thread is a monadic function that takes arguments and produces a result. What distinguishes it from a lot of other components in Urbit is it's not a pure function because it's designed to take input from one source or another, and it's designed to produce output, so it has side effects. The strength of a thread is that it's good for complicated input-output operations. Since I/O is the kind of place where things are liable to failure, we prefer threads in those cases. They can spawn child threads, so you can end up and chains of threads, so you can end up with fairly sophisticated processes where you are, you're downloading remote data and you're getting input from something on your own local system, and then you're using that to go and build a code a certain way and proceed down this pipeline here. So in many respects, a thread is like an agent, but the differences are, one, that it is impermanent. And so it only exists within Urbit while Spider maintains it in its state. And when it completes and returns its value, then Spider clears it out of its state and, it's gone. It's good for processes that fail unexpectedly because of that. It's not going to build up a lot of cruft and overhead in your system. It also doesn't have any upgrade capability. So if you upgrade your system, your running threads will not upgrade. I believe right now threads that are running at the beginning of a system upgrade fail and then have to be restarted. Spider actually actively tracks the different things that are going on with the threads, and we'll try to restart them if something goes wrong in certain cases. All right, so let's see. What is a thread? All right, interpret for me line 12. What is a thread?
It's a function that takes a vase and then it produces some weird form thing that I'm not familiar enough with to intelligently comprehend.
It's
it
a
takes
little
a vase and it produces something.
right. It's a little bit odd to me that we do this cab tar syntax instead of just doing something like this, but it might have to do with what's exposed in the namespace at that point, the way we're treating it. Okay. So strand and form are specialized types. What we're going to read this and say that a thread is a gate that accepts a vase, and it returns the form of a strand that produces a vase. So this means the strand produces a vase. And so what this means is that when we talk about a thread as a type here, we're actually talking about a gate builder. So we're using, the gate building gate pattern once again. So a thread doesn't produce a result. It produces a gate that produces a result. And then the reason we do it this way is because it allows threads to chain together computations that are liable to failure. So, you can chain together an invocation of this gate. And if you do get a result, then you proceed. If you do not get a result, then you decide, okay, do I want to run it again? Do I want to crash? What do I want to try another case? All of these things are options that you can instrument and set up here. The form of a so a form is a strand form raw, and strand form raw. There's all these input and output things. Like this is just a really messy, complicated. Ultimately, we're going to call it the docs call it an asynchronous transaction mold. What makes this complicated is, if you look at the kinds of things that can return are hard coded in here. There's a lot of, if you go look at the definition in LOL, I think it's in LOL, of what a strand is, which is this one here. It's a really complicated gate that produces basically 4 different kinds of handlers. So it's going to be this wet gate that produces a core, and it's kind of a union of 4 different interaction models at the same time. Let me see if I can find that one real quick. That might be in Zeus, maybe. Oh, you know what? It's not. Sorry. I just said the reason why it's not. because it is a builder of a mold. So it's an arm, not a Lustbach. It's a lossless arm, not a Lustbach arm. And yeah, so that describes it as a combination of 4 monads. So there's a reader for input, there's a writer for cards, there's a continuation, which is what takes place when you have a callback, and then there's an exception, and then there's a number of different components of a thread algebra that get defined in here as well. We don't need to get really deep into this unless someday we decide we want to rewrite some aspects of the way that threads work. In general, threads are pretty good, but their interface isn't great. So using threads is generally difficult just because of what the interface is doing rather than anything else. The arms of this that we care about, so we saw form, which is the main type of the strand computation. Pure is our identity computation, and so it takes an argument and it produces a done arg, so you can actually get the right kind of thing out. Bind is you've seen this with a MIC-gal previously, so this is how we combine 2 computations so that one of them depends on a previous one. And then there's an eval, which is used as well. Not sure how often we actually explicitly use eval, but it gets used under the hood when Spider is running these things quite a bit.
Eval is used by conn.c, I believe.
Oh, when it does a direct ovum injection.
I think so. I'm not 100% sure of that, but I think so.
It probably gets used elsewhere too, but
yeah.
Conn in a sense, where they did this very clever, cute thing where there's conn.c, which is conn.c, and conn, khan, vein, which, if the terminology of Urbit wasn't muddy to you before, we're just getting started. It would have been very clever if they'd actually done the same thing, but they don't do the same thing.
Not even close to the same thing.
Right. But at least for the interim, we're stuck with it. It actually wouldn't be hard to rename conn.c, but
Conn.c actually makes sense.
Right, it does, but
that's the problem. It's the khan that makes no sense. Yeah.
That's why you always have to say conn.c.
Yes.
If you're referring to that one. Okay. So now we can go back and we can look at a thread and understand more about what's going on with it here than we could. Like we introduced these previously, and we just said, well, it's boilerplate. Like, don't worry about what it is, just worry about how do you use it, and everything is passed around. But now we can actually talk about like what's going on. So we have a couple of imports. We're unwrapping the spider strand namespace. Then we're producing a gate. So it's remember, a strand produces the form of something. Or sorry, the thread produces the strand. Then we are pinning this M, which is our monad. So our strand, com base, strand with type of base. I have noticed in practice that whether or not this comma is located here doesn't seem to matter. So strictly speaking, we want the type of base here, but in practice, I haven't noticed that it actually makes a difference. Like the strand builder seems to know how to deal with it in either case. Returns a form. So that's the shape of the thing, and this bleeds back into strand output raw, and it knows how to put a wait or a continue or a fail or a done on it. And then you have your chained sequence of computations, which maybe I'll line up here a little bit just for kicks. And then it returns a pure M, which in this case is just return the value, right? Like return whatever the thing is that I wanted back. And then this actually, Dojo is eliding some of the complexity of this, just as it does with generators, where certain things are units or vases or what have you, and then it's packing and unpacking these things as they come in and out of Dojo. So the binder, this was the aspect of the monad that we saw over here. Let's see, where's bind? Yeah. So we invoke my bind as a gate building wet gate. And then it's going to take this raw form and it's going to apply this into a particular form. Messy, but this is where you're actually getting your return types out of when this finishes evaluating here. In practice, McGal is basically always used this way. The only other thing that's really notable about this this short example thread right here is how it wraps up common operations like the bowl and the scry in these in the lib strand IO operations rather than doing them directly. And if you go look at like what is actually the scry arm in lib strand IO, it's just a thin wrapper around a dot ket. Actually, now that I think about it, that might be an interesting way of obscuring the complexity that we've been talking about risking with the removal of dot ket. As we just wrap it in a scry function, and then you as the user don't care. You're just passing it through this function, and then if it needs to McGal or whatever under the hood, it's just running it that way. So yeah, so this each one can depend on the output of the previous one in this case. So you have a mold shape that you're applying it to, you have the monad, and then you have this particular operation that must complete before anything subsequent can complete, because it's going to rely on these values. So, you know, once you define the bowl, you get an hour dot bowl. Although I had not planned it for today, it seems like actually taking a brief digression into McGal would be appropriate here. So if I'm in hoon.hoon, how do I find a particular rune?
You do phonetic, but without the consonant or with the vowels, right? So you do like NCGL.
Yep, then typically that'll give me 3 hits, unless it's a sugar rune and there's some fancier stuff that needs to happen with it to get it proper. And well, sorry, if it's not a sugar rune and it's used a lot in the desugaring of other runes. So McGal is not a sugar, it's a sugar rune, so it's not used in desugaring things, and so it's just kind of a primitive. So it shows up once where it's registered, once where it's parsed, and once where it's matched in the Hoon AST when it's unwrapped. So, you know, here you can see it reading, there's the Mick, and there's the gal. So it reads all these different options here. Okay, so this is what it's actually doing. It's producing a senlus of a senhep q ket col p. All right, so this is a, does anyone remember what ket col does offhand? One's not one that I use very often. Let me see. Obviously, it's a cast of some switch. Oh, it switches into structure mode. Okay, so that's explicitly saying we're doing it by the type of. Okay. And then R, and then bar tiz, tizgar. It's an interesting way of writing that, but buckless 3. So in practice, what this then resolves to is, if we have a statement like this, it's going to desugar to this. So you're going to call the bind of mold on the first expression, and then the gate of the mold on the second expression. Does anyone remember when this was not hygienic and what that meant? So there was a time when if you used McGal, it was structured, the desugaring was structured a little bit differently, and it introduced an extra buck into your namespace. And so if you did a McGal inside of a trap, you had to skip the buck to reset on the trap rather than resetting on something inside of the McGal, which was bad and confusing and a bit of a problem. So McGal is basically our glue, right? It's our way of composing functions together, and so we can use it for asynchronous functions and events. Essentially, is just when we do it. There's some interesting use patterns with building threads. Like there's one called a main loop, for instance, that gives you a way of providing a list of functions to try something against. It almost feels like a parser when you read the code. That's available at threads examples main loop. And it seems like an interesting way of handling an arbitrary number of facts that you're getting back from something or other. There's a number of good example threads in the docs that you can spawn from different things, like how do you spawn a child thread, or how do you use it to fetch a remote resource, and so forth. Now, let's take a look at Spider, because Spider is what conn calls whenever it runs something. So this is an Arvo app Spider. All right, Spider is a Gall agent. It defines a lot of things up here at the top. The ones that are different here. So a thread ID actually resolves ultimately through to pat TA TID, so a special cased atom ARA. This resolves to a thread ID and a cage as the input. A yarn is a list of thread IDs. That's going to be used to track child threads. And then you have two states for things that you're trying. Are you currently building the code, or have you not actively been trying it at the current time? Those are your two options there. The other thing is a thread resolves to a buck hep mold from a vase to a shed conn type. Anyway, if you end up chasing this down, if you chase down all the references, it's basically the thread that you're used to seeing from a moment ago. All right, the state that Spider needs to maintain here. So we have a starting, a running, TID, serving, and scrying. All right. Starting at the bottom. So scrying is a map of sets of remote scries that you're trying to do. So if Gall is trying to remote scry something, then it can set up a thread and try to get that thread to succeed there. So there's a set of thread IDs to scries. Serving has to do with the HTTP API for threads. This is not commonly used today. There's probably some places where Docket or groups or something uses it. Something they featured a little bit more prominently years ago when I was first getting to Urbit, but I haven't really seen discussed much lately. Much like you can call a generator through air, you can call a thread through an HTTP interface, which lets you use the Urbit ship kind of like an AWS Lambda, or a function as a service provider here. So you can just stand up a thread, and then if you need to know information in your front end, you can just hit the thread endpoint to get that information. So this is what's actually tracking what's going on with that, who's asking and where it goes. Running is the set of currently running threads, and there's going to be a path associated with those threads. That's your path on your desk. Starting is the collection of threads that are pending successful execution. And so there, you notice that their state can be trying or vase. And you know, it's a list of thread IDs. The other interesting one here is TID, which I don't think is very well named. Thread ID, well, okay, actually, it kind of is and it kind of isn't. All right, so Spider needs to track all of the threads that it has by a thread ID. So it has a thread ID, a TAT ID. And one of the things that it's tracking then is a map. So this is kind of the primary way it's tracking it, is that it has a map of thread to yarn. So any key in the thread is a currently running thread. We know about it. We know how to deal with it. But it can have an empty yarn. So if you look at what a yarn is on line 10, it's a list TID. So if the list is empty, then you're just running that thread. If the list has thread IDs in it, that's how we're tracking child threads. So if you have a thread that spawns a thread that spawns a thread, this is how you track those down into your system, is by putting them into from the thread ID to the yarn. This data structure seems a little bit kludgy to me, the kludgiest of all the data structures in Spider. You know, there aren't sort of directly protections against it being reentrant or circular or something going on there, but all right. Yeah, so that's the state. That's all it needs to know to track everything. Bunch of upgrade logic and state logic and everything. Let's look for, let's see, you already know we can get a wait, a skip. Let's see if it deals with those in here. Okay, so it explicitly deals with certain cases. Let's see, what arm are we in? We're in take input. So it knows a next, a fail, a done. If we go back to our strand output raw, we can see these 5 head tags that get associated with these things. So we have a wait, a skip, a continue, a fail, and a done. So wait means there's some sort of callback to this point that we're pending. So if you return a thread wait, this means you just hang out here. Skip means we drop handling this thread because it's being handled elsewhere. Continue means we're going to continue the computation because we received a callback that we need. So if we have a wait, then at some point we're going to receive a continue, you know, another thread is going to result in a continue, and then it's going to know how to proceed. A fail means we've aborted a computation and it's going to suppress it from sending the card effects on line 23. And then a done finishes the computation and dispatches the set of cards with that. In Spider, there's a Spider helper core. Yeah, so here's our, I'm calling it Spider helper core. It's only called that in the raw hint. There's not a separate name for it. It's just a helper core. This has all the logic to handle HTTP calls in and out of air, to start and conclude threads, to build code, to handle input, and all of these things. So for instance, thread done is what results when something succeeds. It's fine, thread done. Thread fail. Okay, here's thread done. All right, so we're interested in this one right here. All right, so we are receiving a yarn, which is a list of thread IDs. We have our vase of our results. And so then we are basically constructing what are the actual cards, which are the notices. You remember when you invoke Spider, you have to pass to start, and you also subscribe to the result. So we're constructing our list of results here. If we have HTTP responses to deal with, then we will Tizket them in. If we have scries, remote scries that are outstanding, whatever, then we figure out how to deal with those, or we cancel those, so those are removed from our list of scries. And then we return this whole list of cars and the state that actually results from the value coming out of this here. So like a fail is fairly similar to that. Spider does have some auxiliary scries. So you can scry into Spider. Let's see. Do I have a Zod here? I do have a Zod here. So for instance, let's see. Let's look at. So there's tree. That's going to be a turn. So it's going to return a list of running was a set of. That should be a set of paths, I think. So let's try that. Let's try .ket list path. That's an X scry. And then we're going to scry into Spider, which has its own weird syntax like this. What I do? Oh, GX needs a mark. Okay, there we go. So on this fake Zod, this is the list of currently active scries. So there's some dojo stuff. There's a couple of aqua scries. I don't know why those are in there, but interesting. And then some conn active scries that are coming in from something or other as well. All right. You can only subscribe, if you look at on watch, you can only subscribe for results. So you can subscribe to a particular thread, to a particular result, or to via HTTP. One of the things we import here is we import libstrand. So let's look at libstrand. Libstrand should surprise you. What is libstrand doing?
I don't know what rand is, but it's just whatever gate or core that thing is. It's just giving it that.
Yeah, it's just here's the name of the face of a core that is somewhere in our namespace already. Turns out it's in Zeus, and so my guess is that this was probably in libstrand at some point in the past, and then they decided to rip it out to Zeus, but didn't want to break everything. It's kind of an interesting design pattern there. I don't remember if there was anything in LOL, maybe. LOL, okay, it's in LOL. Okay, yeah, it's just a bunch of definitions. Oh, it's actually where all those definitions was in rand. I don't know why it's called rand instead of something else, but it's computation. Anyway, okay, so now we can talk, now that we know what a thread is and what's going on with Spider, we can talk about conn. All right, so conn, when it was introduced, was basically saying, okay, it's the control plane. What this means is that it's a thread runner vein, and the main thing it's supposed to do is to permit external applications to run threads using a Unix socket. So they can either just inject threads because they want the Urbit ship to do something, or they can inject threads and receive the result through a Unix socket. So if you haven't worked with sockets before, sockets are basically a registration within a POSIX compliant system that you can pass data into and out of, and it kind of sits there as this common buffer that you can use for inter-process communication. So some other, some shell script or Python program or whatever needs to talk to Urbit. One way it can do it is it can say, okay, I know there's a thread inside of Urbit that does XYZ. So I'm going to invoke that thread, and I'm going to watch this socket for a particular result. So basically, conn was a way, it was conceived as a way of Tlon solving hosting problems. Like, how do you control Urbit chips from the exterior with threads? It ended up evolving a lot from that proposal of being in the control plane into its implementation. And right now, it's basically an interface wrapper for spider-based threads, right? Gall is a landlocked vein. We don't have a good direct way of interacting with Gall from the outside. There have been some kludgy ways of doing it in the past, but conn is purpose-built for, I want to talk to Gall, and in particular, I want to talk to Spider. It's not the only case in which a vein relies on a piece of user space infrastructure to function correctly. But it's not that's not a common pattern where, you know, conn depends on Spider, right? It depends on a user space agent to do what it needs to do. And conn is also going to use a cage internally and a page externally. So do you remember what the difference between a cage and a page is as a type? Right. So what's a cage?
Mark and base, right?
Yeah. So mark and a base of data. The page is just mark and data. It's assuming that you don't have access to base mode and you have no way of interpreting a base. And so this is the way we're going to expose things when we're working externally. If we pop back over here and we look now at what the interface for conn looks like, it's not long. I can actually almost without adjusting my screen, I can almost fit it. But yeah, so there's conn. All right, so it produces two GIFs. It produces an arrow or an eval. In practice, you are going to use arrows if you're inside of Arvo. That's your in Arvo target because that's a cage. And if you're outside, then you're going to be handling an eval, which means you're going to be getting the mark in the data and figuring out what to do with it. The tasks are pretty simple too. One of the things I like about conn and lick, particularly as an off-cycle postpone lesson, is they're both quite straightforward veins. Like they do one thing. They don't have a lot of weird edge cases to deal with, so you can just work with them. You know, they're both short, they're easy to read. There's three kinds of tasks you can pass in. Basically, done is your Unix socket management stuff from the Arvo side. But basically, you can pass in a fard, a fired, or a lard. All right, so a fard means we're going to run a thread from TED, FAS TED inside of Arvo. So conventionally, you would have, when this was first introduced, you would have issued a fard to conn to run a thread rather than Spider. A fired was a thread, was and is a thread from outside of Arvo. It's something that's passed to the runtime, and then you get that runtime-based evaluation of it. And then a lard was introduced more recently as an inline thread. So you can actually define something on site, in your Hoon program, you can construct a strand and then evaluate it directly. It doesn't have to be built from clay the way that a fard or a fired needs to. We don't have anything analogous to that for an external thread because we don't really have any libraries that are sophisticated enough to build inline external threads. In principle you could, but we don't really have that now. The invocation itself, if we're going to pass in a fard card, this is what a fard card looks like. So we're going to pass. There's going to be some path name associated with it. What the mode is inside of conn. A namespace value. I am not actually sure what namespace does here. Maybe it was desk. I don't suppose anyone knows offhand. That might have been desk.
I'm pretty sure this is desk because I thought that this was arbitrary, and then I found out the hard way that it was the desk. I'm pretty sure. But I'm only like 70% sure that that's true.
I'm going to put desk question mark in the notes because I am actually I'm actually not sure. And now that I think about it, every test that I've run with conn has been on base. And so I've never actually run into a case where I've had to worry about doing something fancy with it. So, okay. I don't know. Mopful has any of your native planet stuff used conn much?
We use conn.c more than anything.
Yeah. Okay. Well, that's a different
Yeah.
animal.
Yeah.
But yeah. My impression. Okay. So if we're looking at sort of like I guess Tiller, I don't know. Do you guys use conn with hosting stuff at all?
Yeah, conn is honestly like as much as like it's maybe not architected perfectly for the long term, it's like the most useful plane from going from Earth to Mars. We use it for everything.
Okay.
Like,
yeah.
if you want to touch Urbit and make it do an atomic thing, writing a thread for that thing is like the best way.
Yeah. That makes sense. That's always been my impression, is that this was a hosting vein more than anything else. And I know Twan uses it a lot. I don't know what Holium does. They're kind of more tight-lipped about it.
Yeah, I mean, you have like conn and lick, and to use lick for the same thing in hosting, you have to like put something on Mars that reflects the exact interface that you want. Forcibly install an application to everybody's ship. Whereas like with conn, you can kind of just like keep everything on Earth and put it on Mars only when it needs to be. It's a lot more elegant.
Mm-hmm. I do think that kind of big picture, one of the things that I'd like us to do I sort of have this vision of like what I'm calling core user space, which is the stuff that developers on Urbit really have to touch to do things well, even if they're not core devs. And one of the things I want to do for that is I want to sort of go through and really tighten up conn and Spider on their interfaces. There are things they do well, but there are things like the amount of boilerplate you have to include that literally never changes is really clunky. So, I mean, there's one reason too. If you actually go look at conn's documentation, it's pretty minimal. And that's partially because we actually do expect that API to continue to evolve too. So fard means you're talking about a thread name that you have somewhere. A different case here is a lard. We're going to do it with a bar pass, but now we're actually building that gate directly here. It has we're lighting the ket hep, but it has the right shape. It returns a pure M, and then we can go ahead and actually run this here. Now, let's see what it looks like to run this right now, because the thing you always run into with bar pass is okay. So it is oh, it's a Helm high. That's why. Okay. No, the thing you run into with bar pass is from the dojo, you don't have a way of subscribing to GIFs. And so if things get returned, like there is a product that is returned, Dojo doesn't give you any way of catching that gift, taking the gift and doing anything with it. So it just goes away. So in this case, when you pass this, you do get the side effects of Helm High, but you do not get the product back because there's no way to take it. That's another thing I actually would like to revisit for core user space someday. I want a shell that can maintain a queue of incoming gifts, and then you can decide how to route them or what you want to do with them. Kind of more of a bash like routing on things. But anyway, let's see. I guess the last thing is we talked about arrow and avow. Conn has no scries. It's actually kind of funny to look at the vein with no scries, and it's just incredibly simple. It just returns a sig of the right shape. At the end of the day, this is another place where you could actually imagine that wrapping information from Spider, the way that we did get information when we ran the GX here of outstanding conn threads. They're just not exposed right now. Let's see. And then last thing I was going to show with respect to this was the difference between a Spider call and a conn call. So in this case, this first is the return from an agent that is using Spider, and you have to pass a watch, and then you have to poke it with a Spider start. And you have to use the same wire on both of those. And then the result from that is handled on agent. With conn, you do a single pass of a fard or a lard, and you will handle the result in your on Arvo instead, because you didn't explicitly subscribe. Conn takes care of that and then is going to route the gift back to you on Arvo rather than an explicit pub sub. From an app perspective, neither of these is really, like, one's not really superior to the other. I think it's probably just more whatever you're comfortable with using there. All right, lick. I should just have Amadeo do lick. So conn was written by Jake Miller and Joshin primarily. My understanding is that Jake Little Wolford did most of the KHAN side of things, and Joshin did conn.c, and they were launched at the same time, sort of under the same rubric, although it has subsequently become clear that they're doing separate things.
Not completely, right? Like you can inject a thread into.
Yeah, there's overlap.
Yeah,
but
yeah.
Conn does a lot more than that.
Yes.
So, all right. So lick. So lick is also IPC, and it's designed for a different scenario. And in particular, it's designed for cases where rather than having single event injections to trigger some Urbit side process and then get a response, right? Conn is very client server oriented. Lick looks a lot more like a communications buffer model, where you're going to have external processes, nominally hardware. That was the original motivation for conn. And actually the original motivation of all of it was saying, like, well, what if we wanted to use like cryptographic dongles to secure an Urbit ship? Like, what would that look like? And then so lick is much more low level and focused on a noun interface. And it provides it over domain sockets in a way similar to what conn is doing, but it's basically assuming that you're going to have ongoing communication. And so there's this process where a vein or an application asks Lick to open an IPC port, probably, yeah, I guess this is another part of the difference is Lick is Urbit side initiated, right? It's initiated on Mars, whereas conn can be initiated on Mars or initiated on Earth, both of those. But Lick, as I understand it, you have to trigger everything. And yeah, and Mop will jump in anytime. If I'm
Yeah,
like
you
way
have
off
to
the rails.
send a spit a spin task to spin up a port.
Yeah.
Yeah.
Which I guess you could do from the exterior
You can,
if you wanted to instrument that.
yes, I mean you could use conn.c to pass to inject an event to inject a spin card that to inject an event that spins up a port. The
Right.
problem is the routing gets all screwy.
If you're doing it from Earth.
Yeah.
Okay.
You won't have nothing will accept your soaks
Okay.
if you do it that way. Yeah, it's not recommended to do it that way.
Is there a way to get around that? Well, anyway, they don't know what spins and soaks and everything.
No,
are
not yet.
so
We probably should talk about that.
Yeah, we'll jump ahead. So basically, Lick works by opening a Unix socket for a particular process, and then you get serialized IPC communication. So basically, you're going to be passing jammed nouns out. So whatever receiving process is working with this needs to know how to communicate in nouns. You need noun.py, you need something that unwraps it. And then I've got some technical stuff on what the IPC ports are as AF Unix, sock streams and everything, but you don't need to know that unless you're actually really doing some like C-level operations with this. There's a jam format that looks like this. The noun that you're getting, there's V is a version, J is the jam size in bytes.
B is
and
the
then-
jam size in bytes in Little Indian.
Oh, B and then J, yeah. Oh, that's why I changed my syntax midway through.
So that's called newt encoding, and that's what
You guys remember Newt?
Yeah, it's what the serf talks. It's the encoding that the serf talks to the king in.
Yeah, we talked about Newt, but it's been a long time since
It has.
we've had to look at Newt encoding. Yeah, this is Lord.c has a lot to do with this too. Newt.c and Lord, and
Also B and J are both in Little Indian.
I might have missed the talk that we discussed newt encoding in, but I would like to dig a little deeper into it because having been educated on Urbit from like the original Curtis writings and talks, he made a big deal about how Jam and Q were like the single serialization format.
Yes.
Well,
that is
these are jammed.
They are jammed
Yeah.
and queued. They just have a header on them to make them go through the IPC port. The problem.
guess
Go ahead.
My question is if like the goal is universalization of serialization, which I think is desirable. Wouldn't you want newt jamming to wouldn't you want jam to just do a newt jam every time?
No, because
Well-
a jammed noun. Sorry, go ahead, Neil.
Yeah. So a jammed noun has its size in unary, which is kind of weird for a lot of things to read. Like it's just not really a friendly format. Were you gonna add more to that, Mopful?
Yeah. So the problem occurs with the jammed format is you don't know the bit length of the jammed noun. In most wire protocols, you need the other end needs to know how much data to read from. Right? So the idea with the newt protocol is you read the first 5 bytes. That then tells you how much more bytes you need to read for the actual jam. So on Mars, Newt doesn't exist.
Because on Mars, you don't need to know the bit length. You're just going to read them and
Exactly. Yeah, there's no concept of bit length. A noun doesn't have a concept of bit length, but when you hit Earth, the wire protocols require it.
Mm.
Or else I'm just going to be reading 00000 forever, right?
I mean, I think at that point you probably want like Newt Jam at least in Hoon, right? Like it should be fairly straightforward to say like, okay, so if I'm going to store this data on Earth, like Earth processes need to know a little bit more than what Urbit needs to know. So this is how I serialize for Earth side storage, and then this other one is how I serialize for Mars side. That actually like that's tenable, right? You have two serialization formats. One of them, is like a has a compromise, which is that
I mean, again,
process that data.
The Mars side stuff has no idea what Newt Jam is.
You could encode it in the form of a noun. Why not?
Why? I mean, why do you need to know that? I guess
You are though. Like this is, I guess, like Newt encoding is jam encoding. It just has a size header.
correct.
So I guess I sort of I don't understand Tiller's objection.
I think I kind of understand. I think I kind of get it, and Tiller, you can correct me if I'm wrong here, but it's just like strange that we have a slightly like the header, the inclusion of the header on Earth rather than on Mars. I understand why we need it, but related question to this is, how can we get away with not knowing the encoding length on Mars? I mean, I guess it'll always go down to Earth at some point, and like when you're doing, I don't know, inter-process communication of any kind, or you're like serializing packets and names, you have to like include this information, but there's just like not a concept of it at that high of a level of abstraction. Is that the idea?
Well, it's like memory. Like we don't know how big things are in Urbit at all.
Right, you're just given like a noun, and it's like an atom. Like, I guess it's that layer of abstraction where you don't know how it's going to be, what's the word? Like what manifestation it will take when it's on bare metal. And as a result, you don't know like what the, you can imagine a world where these are like ternary instead of binary things, which I think was the point at some point in time, that they were like actually ternary processors or something like this.
Yeah, but ternary's been experimented with. Babbage's stuff was decimal.
But so you could imagine then like the bit length would be different for those things, right? And so it'll always depend on that Earth layer.
And I mean, Mars, so I guess one question then back to Tiller is what okay, so let's sort of think through like what would be the consequence of not Newt encoding things, of just passing out the jammed noun.
So basically it's like you can send a jam noun to Earth, but you can't send that jam noun back to Mars through Earth. Some Earthside process is going to have to read it, and we would have to build some specialized tool. We wouldn't be able to use Unix sockets to get it back into Earth.
I'm not following that, Tiller. Can you restate that?
Okay, so Urbit knows what to do with a jam noun. You put a jam noun in Clay, you mount it. It'll see like there's a jam file here. It'll give you an atom that you can unpack. That's doable, right? But when you try to feed that same data to a Unix socket, that doesn't work. The Unix socket wants a header that'll tell you exactly how many bytes.
So the Unix socket doesn't require a header. The header is given as a convenience for large jammed nouns.
Okay, right. But you get what I mean. It doesn't require the header, but it's nice to have the header. For sophisticated use, you want to have, you need that extra metadata. So the problem I'm seeing is, you have this universal serialization format. It's not actually universal. If you're serializing for the purpose of storing on Earth, than to actually like make that round trip back to Mars. You actually want a newt encoding. So probably if you're serializing for the purpose of Earth-side storage, you'd want to newt encode it on Mars and then send it to Earth.
But Mars doesn't know how big the atom is.
It can figure that out.
It could, but it doesn't. Mars doesn't need to.
It doesn't need to, but you probably want to have that available if you're going to be storing stuff on Earth that you eventually want back on Mars. I think that's like, it started as a complaint, but it ended up as like a proposal, which is that, yeah, we probably want like a standard library function of like newt encode. Like we probably want like newt encoding as like a mark or something, and say like, okay, if you're going to put nouns on clay that you want back in, that you want to mount and put back on Urbit somehow, probably like that would be very useful. That would be very useful is like a mark for newt encoding something.
I mean, with Met, you could definitely get enough information to do this. I'm not really sure what version is doing for us.
Version is there as a placeholder in case the jam encoding algorithm changes in the future.
In case Tiller wins.
Yes. Basically, yes.
But if Tiller wins, then it goes away. Actually,
I mean-
you know what?
I mean,
we
Ames-
can't newt encode in Urbit
You have leading zeros.
because
Yeah.
version is a leading zero.
Exactly. So the Ames does the same thing, right? Ames adds headers to a jammed noun, which is your packet. Doesn't it?
Yeah.
Yeah. Like because you're talking an Earth side communication process, you have to make these affordances only on Earth, not on Mars. I think is the philosophy behind that.
Well, okay. We're gonna keep moving though.
Sorry for the.
I mean, I don't object to it as not being worth discussing, but I want to get through these two. Okay. So basically you're going to strip the first 5 bytes and then queue the jam file and then check the mark and convert the noun into some native data structure.
Oh.
Yeah.
For the record, the first 5 bytes don't go into Urbit at all.
Right, they're stripped by the runtime on the way
Yes.
back.
Yep.
So I don't know. It may end up being moot. Anyway. Okay. All right. So here's our lick definition, which like conn is quite short. So you have task, you can spin, shut, spit, and soak, and the gifts are spin, shut, spit, and soak in direct correspondence there. So to evaluate what it's doing, okay, we talked about like the domain sockets and how they're communication endpoints that we can send data to. What this will mean then is if we want to use, before we look more at the interface there, let's look at like an example of this is what using this would look like. This is from the snake game that we did in a, gosh, it was like a developer call back when we were doing those, to take Palfun's snake game and hook it up to a Pygame front end as a client, as a view and controller. And it was a little laggy with everything, but it worked.
Oh,
but basically here's, what's that?
I fixed it. It was laggy because I was booting an Urbit instance every time I needed to queue something. But we wrote Python. We wrote a Python queue in a Python jam, and we got like 30 FPS.
Okay.
Yeah.
Well, we should hook this up again sometime. I'm curious about that. All right. So basically your life cycle. You are going to pass a spin to register a particular socket here that you're going to communicate with. You are going to send state by spitting data to that endpoint. Control is the path that it goes to. Spit here is the wire. And then you are going to receive back a soak. So you're going to send a spit, you're going to receive a soak. And that has a, in this case, you're just getting whatever your arbitrary data is and
Well,
unwrapping it, handling it.
there are 3 soaks you have to handle that the runtime sends you. A connect soak, which tells you when something is connected to your IPC, a disconnect, which tells you when the last thing is disconnected from your IPC port, and an error soak, which tells you if there's an error.
Why would I want to know if there's an error?
Because if you try to spit
Trying to
something
make my
that's
life
not
hard.
I know, but if you try to spit something into something that's not connected, you'll get an error soak back.
Okay.
That's
Is that the most common? Is that the most common case?
Yeah, yes. That's, I think, this is the only on error soak that Ver sends.
Yeah. Let's see. Did we even look at conn earlier? Conn.hoon? I don't think we really did. I mean, yeah, but I mean, it's like 200 lines. Really straightforward, just definitions. It just takes, it doesn't even have an abet pattern. Like it's so simple. It's just a core. Lick is the same way.
I think the most interesting part of conn.hoon from working with it, because I at one point had to dig into the code to get a better understanding of it, is the definition of shed. I think you noted this when you were talking about it, but it's like
Shed must be in lol.
a shed is like basically, I think it's the form of a thread under some condition. What it ends up meaning is that like what it's taking from Earth, you need to write a thread that actually removes a lot of the boilerplate. Like you can basically start off with your TIS phases.
Mhm.
So it's of like the thread gets built against a subject that includes by default strand IO and all that stuff. So like basically you end up with a different format for threads that's in some ways better, because what you were talking earlier about how a lot of boilerplate for threads could be standardized.
Yep.
Standardized away. And that format per shed actually kind of does standardize away a lot of those things. It asserts a lot about how you're writing your thread, so you can just get to work on the operations.
Okay. That's something to look more into then if we decide to actually revisit and upgrade this part of
Yeah.
Para user space.
I never understood the syntax there, though. I ended up like resorting to an operational understanding of the definition, but it's like, yeah, the type of the bunt of form. Why isn't it not just the form of strand? I don't really get that.
I don't know. This is pattern matching everywhere else it's said though.
Yeah.
But yeah, it's a weird. Anyway, let's see. I wonder if what does that mean? Well, it's clearly not the same thing. Yeah. I don't know. Anyway. All right. So lick is also like not even complex enough for an abet state. Yeah, 132 lines. 3 scries, ADU. Is this the only vein that doesn't, well, conn doesn't have a any scries at all. So I'm watching the Amazon truck try to turn around in my driveway right now, and it's really funny because he's doing like a 12-point turn because he's so big. I think he should have just backed out the whole length, but oh well. Okay, so yeah, there really isn't much to do here. And the reason there isn't much to do here is because everything interesting takes place in lick.c. At the end of the day, it's just passing notices to this Unix duct that Arvo and Ver know about and know to watch.
There is one important note with with Gull's interaction with Lick. Gull prepends the agent name to the Lick port.
Does that show up here anywhere?
No, it shows up in Gull.
Okay.
Yeah. I have to look exactly where. It's been a while and Gull's changed, but if you look, yeah, there it is. So if it's a soak, if it's getting a soak, you can see the name gets changed, right? We pull which agent to send it to, and then we remove the.
Okay, so we have to do a clever routing.
Yeah, and if you do another Control F, I think you'll see the other. You'll see when it adds it to the to any other card that gets spun. You have a generic. Oh, maybe it's.
I mean, it would be a.
It would be with the spit. Yeah, there it is. If it's a spin or a shut, it does the same with the spit. And that's an affordance, so multiple agents can have the same named. It does two things. It lets multiple agents have the same named sockets and puts because it's a path, it's actually a folder. The port is actually located in a folder in your .urb,
Right.
.urb dev. So it gives each agent its own folder, so you can have multiple IPC ports if needed.
I guess that actually that gets built in by lick.c then.
Correct. Yes.
Explicitly.
Yeah.
So let's hop over there now. Var package, var io lick.c. And probably a good place to start would be. So spin starts up the port. So this is also all handled by libuv. In a sense, right? Urbit doesn't exist. It is all Unicorn Velociraptor all the way down.
Basically, yes.
But is that why you chose the kind of sockets that you did? Was just because that's what was in libuv?
Because it keeps the basically because that's what conn.c uses.
Mm-hmm.
And Surf King uses IPC ports as well.
Yeah.
So yes.
Yeah, so basically spin is just registering some bits and pieces, initializing the socket. Let's see what init socket does. Yeah, it creates the path. Yeah, writes the path, and then
a bunch of error handling and weird checks that needs to happen. A lot of this is copy and pasted from conn.c.
Yeah, which we will look at next.
Yes.
I don't know why I did it in this order, but it felt like conn.c was like its own topic. So anyway, those are straightforward. But what's probably the most interesting one is to actually watch the life cycle of a spit. So you get a spit. So this is the callback. And so in somewhere Dawn or somewhere Maine, you register this as the callback for, you've got something sitting in your Unix event, and then a soak would be the other callback. And so you get I don't know, this is some data structure, but you get a U3.
That's the port.
And
The
the data.
lick U
Okay.
is the
This is
driver.
port.
Yeah, that's the driver. Sorry, that's the lick driver properly.
Okay. And then name is the namespace, kind of like desk, or
That is the port name.
okay.
So that
and then
is-
the actual data that you're writing to that port name.
Yes.
Okay. And some unpacking and C stuff, and then lick send noun is when you're actually injecting that data to the port. Otherwise, you have an error and you have to send back the error. Yeah, so there's your error injection going back in on 506. So lick send noun, jam and send noun over channel, which is just a jam from the outside and a newt send and some ref counting stuff. So you know what a U3 newt send is in principle. Maybe we'll take a look at it real quick. Right, buffer to stream. So given a particular stream, write the buffer that's going to go out there. libuv will take care of actually resolving it down to what happens on disk. And then there's the other thing to look at, going back to, I guess I shouldn't really call spit a callback. Soak is the callback.
Yeah. So
spit is the initiator.
No, spit is data going from Urbit to the IPC socket.
Right. That's what I mean by initiator. It's like it's the Mars side hits the Unix duct, hits, and then that's going into the runtime. And lickef spit is what is the initiator in that now it's doing all the runtime, the send down and the newt send. And then there's the sock callback. Why is this not a soak callback? So close.
Because it's the socket. It's a socket callback, right? So if something writes to the socket, you need a callback to say, hey, something has written or something has connected.
Mm-hmm.
Yeah. I misspoke, by the way. You only get a connect when the first thing connects, not when anything connects.
Okay. That just means that this runtime can connect, is what you're saying then, basically.
No, not runtime. It's any external process can connect.
Oh, whenever any external process connects. Okay.
Yeah.
Okay. Yeah. So that's your notice there. If your ovum coming back in, how does the soak actually get back into the Urbit ship? It's not coming in through the read, because that doesn't go straight into the Urbit ship.
No. So sock callback just tells you when something is connected to the socket.
Okay, so it's only for connection.
Yes. Yeah.
Okay, then so there's a different callback then for.
Yes. If you just control F soak. Yeah. Again, because that's the error soak. So you might have to find a few of these.
That's a close event to Arvo and stop reading.
Let me find it. It's been a while.
More poke.
Yes.
Okay.
Yeah.
So what is a more poke?
The more is the event callback from so it's when you get a byte stream from the socket, it's the callback for this. This is again copied, cargo culted from conn.c, so we use the same verbiage as them. Yeah. To keep it easy.
Yeah, that's fine.
Yeah. So that pointer, the the pointer you get there is the channel. So that is the channel. You can see that on 165.
Yep.
We get the channel. The channel has a back pointer to the SANU, and then the GENU, which is the port itself, and then the port has a pointer to the LIC driver. So that's how we kind of string that data through all these callbacks. You see the 173, you have the Xeno or the Q Xeno with.
Yep.
So we're using let's use Xeno queuer, which is that CILU there, to queue out the byte array. If it's not a none, so if it's not an empty queue, that's not an empty noun. We sorry, if it's an empty noun, or if it doesn't have the format of mark noun. So if you can't split it up into a cell you error out. If not, you send that to the correct device the correct port.
Mhm.
In one so you get the 186 changes a C string into a path, and
Yeah,
then you
that's
generate the soak and you queue it up for injection, for the ovum injection.
okay.
Yeah.
Yeah, that makes sense. A lot of nulls hanging on the end here.
I think that's I think you have to look at U3.
I know this
Here.
stuff is a lot of this stuff is just opaquely.
Yeah.
Uh,
Yeah, what is it? U3 peer. So you give it like you give it the egg, which is, you give them the ovum, which is the first thing, and you give it a pointer, a data pointer, which is the first null, and news. So that's the function that gets called if it succeeds, and then a bail, the function that it calls if it fails.
we're going straight to the null pointer, and
Yeah. Basically, it says if this fails, this shouldn't fail. If this fails, don't do anything.
yeah. Well, that seems fine.
Yeah.
At this point. All right, thank you. All right, let's look at conn.c then as, the big one. This is a driver, basically. Just think of it as a driver. It's part of the king or earth. And its intent is it's going to expose a Unix domain socket at peer.urb faz conn, conn .sock. Conn.c. So this will be .urb conn.sock. All right. The point of it is that you can read, state. You can enqueue events easily, and you can send arbitrary commands for pack, meld, whatever else you want to do. That's the vision of it. The main connection to the vein conn is that it special cases some of the inputs for Urbit that are more common cases here. So it's going to accept Newt encoded jammed nouns that are going to have a request ID. They're basically going to look like this. They're going to have a request ID and then some command, and then the arguments that go to that command, right? So this is your special cased conn vein stuff, which is if you send it a fired, it knows how to deal with that. Otherwise, you'd have to like actually construct the ovum and inject it that way. Then there's some runtime commands and scry stuff. I haven't actually seen things done with peel, for instance.
Piri
Oh, this is
uses
what
that-
all the mass stuff comes from, huh?
What do you mean the mass stuff?
Mass.
Oh yeah. Basically, I was gonna say
Yeah.
Piri use this a lot for debugging, like dropped packets and stuff. The runtime publishes some useful information for debugging purposes.
We've got an outstanding bounty that got half done. A lot of the proof of concept stuff was done to get the result of calling mass back into Arvo. So you can make Hoonside decisions about, like, is it time to pack or meld or whatever. There's a little bit more work to do there, but honestly, I think it's probably an afternoon for half a star. So, you know, if you're thinking about it, it's out there. Let's see. Yeah, pretty good description of like what's going on with all these pieces. The con more poke. So this is our message read. We've gotten something in that we need to deal with here. So it's doing the same kind of process that Motfo was just describing, where it queues, checks whether or not the queue is valid, does some other kind of validity checks, talks about the connection, and then switches on the kind of thing that you're trying to inject at some particular point. Or is it the fire? Is it the peak, the peel, whatever you have? Yeah, so this is where we're special casing aspects of the con dealing here. Ultimately, you're still just also injecting an ovum, but you're doing the manual construction on it to make sure it's correct. There's a callback handler at peak CB. All right, so this is your scry stuff. Send noun. There we go. So jam and send the noun in there. And then the read peel. This was the part I was more curious about there, which is the runtime pokes for things. So it switches on. You can do a help, which dumps a whole bunch of information. You can do a live. You can do a mass. You can do an info. This is the sort of stuff that's like completely undocumented.
What do you mean? It's documented right there.
It's conn.c. Oh, this is in the click. Oh, this is in the click stuff.
It's all in the click stuff also. But I'm saying it's documented
Yeah.
in the code. Yeah, no, the click stuff actually does a good job kind of explaining all of it.
There's also a conn.c usage guide.
Which is in the click repo. Oh, in the tools
that-
repo. Yeah, it's one of the. Let me see if I can find it. It's part of the
Yeah,
wiki, I think.
Yeah, I've got it here. Yeah. Sorry, actually, now I'm warming myself back up to this. Is the problem is I wrote this lesson and then I didn't teach it, and then I wrote another lesson, and now this one's like, I'm in azimuth mode, not in remembering what I was doing with conn.c mode anymore. Let's see if there's. Yeah, this is all Urbit eval. Operations here. Yeah, I've never really used click. It actually does look like kind of a cool little.
It is
Cool little
I
tool.
think Gary, do you guys use it?
No, click is actually in a straddling position between reference implementation and load bearing infrastructure. Do you ever talk to the guy who wrote it about like any problem that it has? He'll tell you that it's 50 lines of bash, go write your own. So we use our own like
Okay.
con
Who
wrapper
who,
for
who wrote it?
right.
Alex and
Alex.
myself. I know Native Planet uses it, and Talon uses it as well.
It shouldn't be used as load bearing anything. It's meant to be like a reference implementation. So you write your own that covers your specific needs. Like for one thing, it has no hope of Mac compatibility. So
Oh yeah, not at all.
because like yeah, different versions of Netcat or something like that. I don't know. I got briefly into it and then decided to black box it.
I mean, it basically wraps the Urbit eval and netcat stuff into a single command, so it's a pretty small piece of software, but I find it useful.
Yeah, it is useful on Linux.
Yes, which is what you're hosting. Yeah.
Well, makes sense.
Mm-hmm.
Yeah, that's basically what we have for all these pieces. Yeah, conn just runs through and dispatches things, knows how to build things and dispatch things. So yeah. Questions? These are all very runtime connected components at the end here. Actually, Mopful, you and I were talking about like the difference in philosophy from the white paper era of, Mars doesn't call Earth as an operating principle.
Yeah.
Have you thought about that in terms of like what conn and lick are doing more?
I mean, Mars, I think that philosophy still holds. With Lick, right? Mars doesn't call Earth. Mars opens a connection to Earth, and Earth calls Mars through it, right? It opens a pinhole saying, "I will let anything talk to me as long as they understand nouns." And they don't talk to arbitrary parts of me. They only talk to parts of me that are expecting this communication.
Mm-hmm.
Which is it's a bit different than Mars calling Earth in the sense. With conn.c, which I think is more relevant to the question than conn the vein. With conn.c, what you're really doing in all those different cards is telling the runtime to do something. Right? With the thread, you're telling the runtime to inject a thread to run a thread in Arvo. You're telling with peak, you're telling it to scry, peel, ovum, you're telling it to inject a raw event into this ship. So even with conn.c, you're not really having Mars call Earth. You're having Earth manipulate Mars.
Mm-hmm.
So I think that philosophy still holds. I mean, I think that philosophy was broken with Iris at its core, right? Iris is the vein where Mars calls Earth, right? You're saying, give me this piece of information located on Earth.
Yeah, that makes sense.
Right? So, yeah, so Lick was the second iteration of the vein, Lock, which was the original one, did this through ioctl, and
Yeah, I remember that.
yeah, there's a bunch of security and portability issues with that, and that was very much Mars calling Earth.
Where does
That was
that live?
Lock.
Yeah. Did that end up in a branch or?
It might have been. There might be a PR with it. Let me see if there's a Lock PR.
It would actually be interesting to write that up too.
Yeah, there's Lock
like,
here.
This was a dead end for certain reasons, but here's the work that was done on this particular vein.
Yeah.
So
Yeah, I mean, this was operational and stuff. We were able to send direct RS-232 messages and such, but it got when presented to core architecture, it I don't want to say it was poo-pooed because that's not fair, but it was criticized and deemed not worthy fairly, I would say.
yeah.
But
I
yeah,
still think it's worth writing up for USTJ. Like, here was a
an attempt. I might write a paragraph or two about it. I don't want to
just
spend
to but
much
like
time on it.
why it was tried and why it was not used
Yes. Yeah.
ultimately.
Yeah. I think that's fair.
So, all right, all.
Sorry.
go
One
ahead.
other thing about Lick that is important to mention is when it gets a what's it called? A born. When it
Yep.
gets a born task, which basically says the new runtime has started, it sends a disconnect to all its ports. Which is important because if when the runtime stops, the ports get shut down and everything is disconnected. But Mars doesn't know that, so the only way Mars knows that is with the born vein.
Are those like tracked and reopened, or are they just all shut, and you just have to reopen them manually?
A disconnect is not the same as a shut. A disconnect means nothing is connected to it. So it's a disconnect soak. So it Lick will Lick opens it when when it gets a born command, the vein does two things. It sends a list of all its ports back to Ver, so Ver can open them back up, and then it sends a disconnect soak to all the owners of the port.
So, just from my understanding, what is the difference between a soak disconnect and like a true shut or
a shut removes the port from Earth. It closes the line of communication. It says no Earth process can talk to me.
Okay, so it actively, like, there's a file there, right?
There's a file. The file will get removed.
Okay. Okay, so that's what happens when a shut happens. What happens when a disconnect happens?
When a disconnect happens, it means the last. So a disconnect soak happens when the last Earth process is disconnected from the IPC port. The Ver then sends this to the vein. The vein then notifies the owner that, hey, none of your messages are going to go through because nothing is connected.
I see. So Ver actually handles that whole part where it notifies all of the communicating processes on Earth to no longer connect to the socket, and then after that it sends this.
No, other way around. So you have the Python process, right?
Yeah.
Python process connects. Sorry, you have a Python process and the Gull process.
Yeah.
The Gull process sends a spin to open up an IPC port. That goes to Ver.
Yep.
That goes to Lick, then goes to Ver. Ver then opens IPC port.
Then this is when the file is created.
This is when the file is created. The Python port connects to that file.
Okay.
This Ver gets notified of that connection, passes, if it's the first connection, it passes a soak to the gall agent
So
that says, hey, something is connected.
okay.
Okay. When the last process disconnects from the IPC port, Ver gets notified of that.
And so really quickly here, I'm wondering, does this happen when there's like a runtime upgrade? Does Ver itself initiate all of these disconnects, or how does that work?
When you shut it down, Ver will just shut down all the ports, all the earthside processes will lose their connection.
Okay, they still remain, like, they're not shut. They're still living on as files on your machine.
No, they're deleted. When Ver shuts down, they get deleted as files on the machine.
Okay. So a shut at some point does happen, but then they're all like reopened.
No,
after
a shut only modifies the Arvo state, the lick vein state. If you look at the state of lick, you have something called owners, which is a map from name to duct, which is the name of the port to whoever we want to send soaks back to. When you send a shut command, you delete that. You delete that name.
Okay,
you say this port no longer exists.
So when there's a runtime restart, all those connections, those ports, they get closed, right?
Maybe they get closed on Earth. They stay on in Lick's state.
I see. So they're still Lick. So like, I mean, at this point, like at this exact like instant in time when the runtime is upgrading, they are like the Earth. Whatever things look like on Earth, those ports might be closed, but Lick still understands them as being open, like internally. Like it's not running, but okay.
Correct. Yes. Yeah.
Okay. So now let's go. Now let's continue with this piece. Okay. So the runtime is restarting. What's happening now?
It sends a born command to all veins.
Okay.
When Lick gets the born command, it sends Ver back a spin card, a spin gift saying, hey, open up this port. Ver then will open up all those ports, but it also sends a soak, a disconnect soak to all the gall agents saying, hey, nothing is connected to your port.
I see. Okay. Okay, that makes sense. So
yeah.
So the state in, okay, let me just make sure that I'm understanding this right. Like from that point onward, from when the runtime restarts. So like the runtime, you get a new like a kernel version or something. It shuts everything down. As part of that, the Ver will actually close those ports. So there's no ports. There's none of these files on disk. But Lick itself actually has like in its state information about all of these open ports, all these open IPC processes.
Yes.
So then, Arvo Arvo reboots, goes through that whole process, and when it does, it sends this born card to all of the veins. And when
Arvo never reboots, right? Ver restarts. Arvo is a solid state interpreter, but yes, that is correct.
Or I guess when it goes into the next stage, right? It has to it receives the next version that gets compiled, and then that gets like there's that like 5-step process or whatever.
So this doesn't happen on Arvo updates. This only happens on restarts of the Ver process. Restarts of the runtime.
I see. Okay. So this would be like when you shut down your Urbit and then you turn it back on.
Exactly. Yes.
Okay. So when that happens, So when that happens, the born command gets, well, I guess Ver would then inject a ovum of born to all of the veins. And what'll happen is that Lick, it'll have its like list of like, here are the ports that I did have open when I was last, running.
Yep.
And it will then propagate disconnects to all of the existing, like, I guess, what would you even call them? Like, I guess whatever's like open already, it'll just like.
I call them owners, but it's basically the duct. Yeah, it's basically it passes it back on the duct that last opened it, similar to how air works.
Yeah. And so then those will be informed that the last connector on all those has been disconnected because they were effectively shut and then open again. Well, I won't use those words.
Closed and open is fine.
Closed is open. Yes, closed and then opened. And so, okay. And so now it's like, okay, I know that those are disconnected, and then, but those, those ports effectively will be rebooted when Bear gets rebooted. Like they'll be reopened
Yes.
rather.
Yes.
Okay. Okay, and then yes, then it does this so it can notify all of these, like the ducks or the owners of all these ducks, that if there needs to be like some like reconnection or sending of some data, it can do that at that point.
Exactly.
Okay. Okay, that makes sense. Thank you for going through that
No,
step
of
by
course.
step. That,
Of course.
that makes
It's-
a lot of sense, because yeah, you would need
Yeah.
to do this when you reboot Bear, like of course, because
Yeah.
it's going to shut all those ports when it shuts down.
This was a big design thing when writing this, is how do you deal with one thing having a stable state and the other not.
But okay, that does make sense. Thank you for going through that explanation. I think that's the only like big question that I had.
All right, cool. Well, I don't know if I have much else to add at this point. These are, like I say, these are good veins in that they have definitely introduced a lot more control over your Urbit ship than you used to have. You know, if you go back to, you know, 2021 or so, you were stuck with, remember Lens and herb.py, where there were
Unfortunately,
yeah, there were a few like pre-packaged things you could hit with HTTP and you could trigger, but doing anything else was really difficult. So it's nice to have these now, and you know, like I say, I think we could do with rethinking, reworking threads and Spider and Conn somewhat, but in general, it's pretty good design, and it's a very helpful part of the system to be working with. Thursday, also US morning, we will cover Jail and Azimuth, and that will wrap up Core Academy. You've seen some other notes that I've sent about what we're looking for in terms of finished homework and everything. And January 28th is our target date to get all that wrapped up, and then I will get things actually graded, because I won't have the gumption trap of having to grade them twice, which in practice turns out for me is like, I never do it if I know I'm gonna have to do it twice. So and then we'll get the gore issued, and hopefully get you on as complex of a project as you want to be involved in. So